Okay, we're on number 9, and we're told here that the distance between negative 3 and 1 is 4 as the figure below. So they're saying negative 3. Let's point out negative 3. That's right here, and positive 1. Now we're talking about the distance. And we were using the distance before, and we're dividing it by 2 to find the midpoint. Maybe they should have shown us this before, but we're going to go ahead and follow the instructions to simply calculate the distance, right? So we know it's 1, 2, 3, 4. So the distance is 4. Remember, the midway point is in between. This would have been the midway point, okay? But the distance would have been equal to 4, right? Let's call it D for distance. And so that would take 4 steps, okay? So let's go ahead and use the problems we have here from A to H and find the distances. So the first one is 2 and 7. So the distance between 2 and 7, very elementary in the sense that we're just simply counting 1, 2, 3, 4, 5, right? So there's the distance would be 5. Now I'm just going to point to you that we would have been able to simply subtract 2 from 7. Okay. Now there's a relationship in math here that I want you to just sort of start seeing. But when we start getting into negative numbers, it gets a little more complicated. And this is probably the one area in math that a lot of students struggle with in terms of dealing with negatives and positives and subtracting. But we saw the relationship between 2 and 7 as a distance of 5. Okay. Now let's go with negative 2 and negative 7. Okay, let's swing on down here. And the relationship that we have mathematically between negative 2 and negative 7 is similar. Okay, the distance here is 5. Okay, we counted 5. I'm sorry, we counted 1, 2, 3, 4, 5. And again, we have a negative 2, a negative 7. Okay. And if we were to subtract these two, it would actually, now we're starting in a negative side, so a value, in terms of value, that would be different than just say the distance, okay? But we know that there's a relationship of 5 in between negative 7 and negative 2, okay? And we'll go into values later on. Well, because you might say, well, the distance, or negative 7 minus negative 2, would actually be negative 7. But we're using this in terms of just distance, and we're measuring it as an absolute. If I were to take 5 steps to the right, okay, from 2 to 7, okay, that would be 1, 2, 3, 4, 5. Well, that would be 5 steps, right? Now, if I took 5 steps from negative 2 to 7, that would also be 5 steps. Now, we're moving in a negative direction, but it's still 5 steps, okay? I can't actually do a negative step unless I'm only speaking in terms of the direction or relationship. But there's still 5 steps. I could still count them. So that's what we're really just counting, is the distance, okay? Now let's go to 0 and 8. What's the distance? Now, without you doing the simple counting method of 1, 2, 3, we know it would be 8. We also know that the distance between 0 and 8, or the difference, is 8. Okay? And of course they're going to give this us in a negative as well. From 0 to negative 8, again, that distance would be 8. Okay? It would be in a negative direction, but they are 8 nonetheless. All right. Now we have 3 and negative 3. Now we're going to start mixing it up a little, challenge you a little. And what's the difference, or what's the distance between these two? Okay, well, I would have to count. I can go in either direction. That'll be 1, 2, 3. It would take me 3 to get to 0, and it would take me another 3 to get to positive 3. So that would be 6. Okay, and again, you may see that number relationship here. We'll go deeper into that later on. But the distance between 3 and negative 3 is 6. Now let's look at 10 and negative 10. And again, that same relationship exists here. I would have to go 10 steps from negative 10 all the way to 0, right? So I would have 10, and then I would have to take another 10 steps to get to positive 10. So I'd have to add 10 to that, and that would be 20. We could have said before that would take us 3 steps plus 3 when we went from negative 3 to 3. But here, I'm definitely not going to count all these, so I'm just putting the numbers here mathematically. So the distance between negative 10 and positive 10 is 20, okay, in reference to our number line. Okay, now let's go on to our next one. We have negative 6 and positive 1. Okay, negative 6 and positive 1. So let's circle negative 6 and positive 1. Now, what's the distance? Well, I know that to get from negative 6 to 0 would be 6 steps, right? So that would be 6 steps. And then there's only one more, so I'm going to add 1. So that would be 7. The distance between negative 6 and positive 1 is actually 7. And again, I'm just taking that shortcut method of knowing the distance between negative 6 and 0 being 6 and just adding that 1. Now let's go on to our last one. And what do they do? Well, they give us the, let's say, something we might deem as the opposite. We're going to have negative 1 and positive 6. So we have negative 1 and positive 6. And again, I could look at the distance from 0 to 6, I know is 6. All right, and then there's just there's 1 here. So I can just say 1 plus 6. And again, we come up with 7. The distance between negative 1 and positive 6 is 7. Okay, so just I want to reiterate that we're talking in terminology that they're giving us. The distance between 2 points, one being in a negative and one being in a positive. It's just a math concept. We're going to go deeper into that mathematically speaking in terms of how we add and subtract negative numbers. And again, it is one challenging area. You have to be very careful. It's a very tedious process of applying the positives and the negatives properly. But at least you can see, for instance, and what's most important is that you're seeing that the distance between negative 10 and positive 10, okay, is quite a distance. There's 20 in between here. Okay, so we're going to need to apply that, and when we do our math and we have problems where we're adding and subtracting, does this make sense? And in this case, we can see that it makes a lot of sense. Okay, the distance between 10 and negative 10 is 20 because we're looking at it visually. So now we have number 10. It says write each of the following statements in symbols. Okay, letting x, x is back. Let x represent the number. Now we have a certain number is less than 0. So x is going to represent that number. We don't know what the number is. It's a certain number. So since we don't know what it is, it's an unknown. It's a variable, let's call it. We're going to use x, and we're saying that it is less than 0. So we'd write x is less than 0. Oop, I wrote 1 there. It's actually going to write 10. So x is less than 0. And what would we know about x if it were less than 0? Well, it would be a negative number, wouldn't it? Huh? Right. How about the square of a certain number is more than 5? The square of a certain number. So let's write the certain number x, and the square means it's squared. It's x squared, means x times x. We could simply write that as x times x if you're familiar with exponents, but that's x squared. Oop, let's put it back. And what did they say? That it is more than 5. So x squared is more than 5. So we're writing the expression as they are telling us. Now, the sum of a certain number and 1 is less than 10. Now they're adding sum. to this. Now, we know sum means adding. So we have a sum of a certain number and 1. So the sum of a certain number and 1 would look like this, x plus 1, correct? And it is less than 10. So that would be less than 10, okay? Now, we can also write this, and you're going to learn how to use those parentheses later on. Particularly, in this case, we're not saying that x plus, or we're not saying that 1, remember we use parentheses to separate, we're not saying that plus 1 is less than 10, and we're not just adding x to it, or we're not saying 1 is less than 10 and then adding x. We're saying that this complete sum is less than 10. So it's very important because again, this the less than sign isn't necessarily part of the order of operations in this. Though if there were an equal sign, then we would certainly be dealing with order of operations. But we're not necessarily using that here. We're just expressing it. Okay. Now, lastly, we have the quotient of a certain number, and 2 is more than 8. The quotient of a certain number. Now, quotient means to divide. The quotient of a certain number and 2, which we would write x over 2, right? We could write it that way. Another way that we could certainly write it, you may have seen, you have used in the past, is this way, right? X quotient, but we're not using that anymore, all right? So we're discarding that. That's not part of our math language, or at least the expressions that we use. But we're saying that the sum of a certain number and 2 is more than, so I'd have to write more than 8. So that would be how we would express that. Okay, so that's the end of our exercises, and you go on and use set number 3, challenge yourself to do similar problems.